Today we'll be working on the following problem. We want to construct a sequence of continuous function f sub n from 0, 1 to 0 infinity, such that f sub n of x goes to 0 for all x in 0, 1 as n goes to infinity. And the integral from 0 to 1 of f sub n goes to 0 as well as n goes to infinity. Now, the supremum of f sub n is not even Lebesgue integrable over 0, 1. So pause the video if you want to work on this problem by yourself. Okay, let's see what is our solution. First, if we look at this problem, it's very similar to the condition and the conclusion of Lebesgue's dominant convergence theorem. So if we recall Lebesgue dominant convergence theorem. Basically, it says if f sub n of x is a measurable function, goes to a measurable function of fx, and then the f sub n of x is dominate or bounded by some integral, Lebesgue integral functions over measure space omega, right? With the Lebesgue measure. And then we can conclude like f of x, then this implies f of x is also Lebesgue integrable. And then the integral of f sub n of x also goes to the integral of f of x over this space, right? This basically is the Lebesgue's dominant convergence theorem. So if we compare with this, like first of all, this tells us like in the Lebesgue's dominant convergence theorem, this f sub n of x doesn't have to be continuous. So here in this problem, we want this continuous function. Even though the condition like the supremum of f of n is not Lebesgue integrable, but the conclusion still holds, right? The from this, like here in this case, g of x is just f of x is just 0, and then the integral f sub n of x goes to 0. So let's see, how do we construct such a sequence? So if we do something, this is clearly one of the construction, right? So for any n, we can divide it in from divided 0, 1 into, we divided by 2 and by 2 by 2. So basically, each part 2 to the n parts. So if, let's say this is 1 over 2 to the n, and then here is 1 over 2 to the n minus 1, right? So now we want to define a function like here is like a triangle shape. So from 1 to 1 over 2 to the n minus 1 to 1 is 0. And then from 0 to 1 to 1 over 1 to 2 to the n is also 0, but in between is like the triangle shape. And then the height of this triangle we can define to be 2 to the n plus 1 over n. Okay, so if we define such function f of sub n, so for any x in 0, 1 interval, clearly when n is bigger enough, let's see, x is somewhere here, right? and then so we can do x sub 0, this x-axis. So for x sub 0 here, so n bigger enough, like 1 over 2 to the power n minus 1 is less than x sub 0, right? Is less than x sub 0. Is n large enough? This tells us like f sub n of x sub 0 goes to 0, right? Because it's actually 0 itself. So and then f sub n is continuous because it's clearly a continuous function. Now all we need to verify is, okay, goes to 0, and okay, first we want to verify this, right? From let's compute the integral from 0 to 1 f sub n of x, and this is just the area of this triangle, which is 1/2 times 1 over 2 to the power n minus 1 minus 1 over 2 to the n. This is the base, and the height is 2 to the power n plus 1 over n, right? This is just 1 over n. Goes to 0 as n goes to infinity. Right? So now lastly we want to verify the supremum, right? Is not Lebesgue integrable. So here from 0 to 1 g of x, this interval, first we know we can divide, because by construction from 1 over 2 to the n to 1 over 2 to the n minus 1, this interval, and then from n to 1 to infinity, this is actually the interval from 0, 1, right? We first divide by 1/2, and then 1/4, and then 1/8, and etc. This is 1. So we add all this interval together. This becomes the interval of 0, 1, right? So now this can be written as like, n from 1 to infinity, and then from 1 to 2 to the n, 1 over 2 to the n minus 1, this interval, and the g of x ds. So g of x over here, right? This, by construction of f sub n, so this is clearly 1 over 2 to the n minus 1, this interval, because g of x is defined to be the supremum of f of n. This is bigger than f of n x dx, right? And then by construction, the f sub n of x over this interval from 1 over 2 to the n to 1 over 2 to the n minus 1 is just this triangle shape. So the integral of this is just the area of f of n, right? The f sub n, this triangle. So which is 1/2 times the base length, and then time multiplied by the height, and which is 1 over n. This is a harmonic series and goes to infinity. As in the sum, right, goes to infinity. So basically, this actually equal to infinity. So which tells us g of x is not Lebesgue integrable over 0, 1. So that's it.